let's go over these practice problems for 2-6 on solving absolute value inequalities. We didn't have time to go over our Jamboard practice at the end of class, so we'll use this video as a nice substitute. So our first step when solving absolute value inequalities is we want to make sure we have the absolute value isolated. For example, number 2, which is number 5 on your homework, we're currently subtracting 8 from the absolute value, so we'd want to add 8 to both sides. So we have the absolute value of 6x minus 7 is greater than or equal to 11. Okay, so now both 1 and 2 are isolated, and we're ready to determine is it an and inequality or is it an or inequality? Then we'll set up the two inequalities, solve and graph both. So if it's less than or equal to, it's an and inequality. So number 1, because it's less than or equal to, we can determine right at the top that it's going to be an and inequality. This will help set up your compound inequality, and at the end it will help you know that your solution is correct, and it will help you graph it correctly as well. So we know it's a less than, and we know it's an and, sorry. So set up the right side. Just write the inequality as is, without the absolute value symbols. And then we always want to flip the inequality symbol and make that value negative. Now we're solving this and compound inequality like we did at 2.5. And to do that, we want to isolate x in the middle. So we'd want to start by subtracting 2. And make sure you subtract 2 from all 3 sides to keep this inequality balanced. Then we're dividing all 3 sides by 3 because we're currently multiplying by 3. Five thirds is equal to 1 2/3. It's pretty common to get one fraction, at least one fraction in these, because there's only so many integers that it could equal. So just be aware and just approximate where that fraction lies on your number line. So let's set up our number line. We want to go, increasing by 1 will be just fine. It's going to be closed at both ends, both at 5/3 between 1 and 2, and -3. And it's an and, so we shade in between. Right, just to be sure, so it'd be less than or equal to 5/3, which would be this way. Greater than or equal to -3 would be this way. So the overlap represents the possible solutions. So we know we solved it, and then we graphed it correctly. Now number 2, we already isolated it. So now we're ready to determine if it's an and or an or. Greater than or equal to or greater than is going to be an or inequality. Okay, so now we set up our two inequalities. Set up as is without those absolute value symbols. Or (6x minus 7) is less than or equal to -11, right? So we declared it as an or because it was greater than. Flip the inequality symbol, make that value negative. Now we're ready to solve. Now the steps for solving are going to be the same, so we can do it all at once if you'd like. We're multiplying x by 6, so to solve, we'll divide both sides by 6. So we get x is greater than or equal to 3, or x is less than or equal to -2/3. Make sure you have or as part of your solution because it's a part of the solution. It's an or inequality that resulted from the absolute value inequality. So then we go to graph. X is greater than or equal to 3. Be shaded to the right. X is less than or equal to negative 2/3. Would be shaded to the left. So we know we did this correct because we knew it was an or going into it, and it graphed as an or, so we must have solved it correctly. For 9 or 10, we're going to write an absolute value inequality from the given graph. So first we want to see what is our new midpoint. And both of these have a midpoint at 2. That means the graph shifted from 0 to 2. So for that, we're going to write x, my absolute value of x minus 2. Okay, that minus 2 represents what the midpoint is. It's always going to be minus, unless the midpoint was negative, but we won't see that in CP Algebra 1. We'll just see positive midpoints. Okay, now the other piece we need is we need to determine the inequality symbol. So because number 9 is shaded as an or, and both are filled in, we know it's going to be greater than or equal to. Because 10 is shaded as an and it's open, we know it's going to be less than. And then what it's greater than or equal to or less than is the distance from our new midpoint. And both of these have a distance of 3 units. So the absolute value of x minus 2 is greater than or equal to 3 for number 9, and the absolute value of x minus 2 is less than 3 for number 10. When you're writing an inequality from a graph, you're always more than welcome to check to make sure you wrote it correctly. To do so, you want to take the absolute value inequality and solve it and see if it matches the graph. All we have to do is flip the inequality symbol, make that side negative. So we get x is greater than or equal to 5. X is less than or equal to negative 1. X is less than or equal to negative 1. X is greater than or equal to 5. Let's check the next one. So flip the inequality symbol, make that value negative. So we have x is less than 5. X is greater than negative 1. X is greater than negative 1. X is less than 5. So that matches because we have the shading as the overlap. So both of these inequalities check out. So we know we wrote the correct absolute value inequality to match that particular graph. That's it for the Jamboard practice assignment on 2-6, solving absolute value inequalities.